So the second type of sequences and series that we're going to look at are geometric sequences and series. And so we're going to look in this video at geometric sequences, and then in the next video we'll look at geometric series. But geometric sequences is just a sequence that is multiplied or divided by the same number to get the next term. So arithmetic was when we added or subtracted between terms, and now geometric is multiplying or dividing in between terms. And so the common ratio is just the number that is multiplied or divided by each term, and this is represented with r equals whatever that number is. So we're just going to look and see if these sequences are geometric, arithmetic, or neither. If they're geometric, we're going to find the r value, and if they're arithmetic, we'll find d value. So for A, I'm going to look and see what the pattern is, and so I'm looking to see what I would do to get from 5 to 15, 15 to 45, 45 to 135, and that would be multiplying by r. So this is a geometric sequence, and my r value is 3. And so that has to be constant. Like if this was multiplied by 3 to get 15, and this was multiplied by 3 to get 45, and then this number was like 90, then we cannot do that. So it has to be consistent between all the terms. So you don't need to just check the first one and then quit. You need to make sure that that's consistent for all of them. So B, I'm going to look and see what my pattern is. It looks like I'm adding 15. 15 plus 15 would be 30. 30 plus 15 is 45. 45 plus 15 is 60. So this is arithmetic. And the D value is 15 because I'm adding 15 to each term. Now, part C, you can see that the terms have alternating signs, and so most of the time when that happens, that's going to indicate that your sequence or series is geometric, because you would be multiplying by a negative number. But let's just make sure that that's right. So I would need to multiply by negative 4 to get to 20 or negative 24. And then 24 times negative 4 would give me 96. Then 96 times negative 4 would give me 348. So this is geometric, and my r value is negative 4. Now part D, this is a sequence that looks like it's going up by 12 each time. 8 plus 12 is 20, 20 plus 12 is 32, plus 12 will be 44. So this is going to be arithmetic, and the D value is 12. And then part E, I've got 5 to negative 1. That would be subtracting 6. But if I subtracted 6, I would not get negative 8. Right here, I would have to divide by 5 or by negative 5 to get negative 1. But if I divide by negative 5 again, that definitely doesn't give me 8. So this one is neither arithmetic or geometric. Alright, so we want to write the first 5 terms of the geometric sequence. A1, A2, A3, A4, A5. And I know that A1 is 6, and then R is 1/3. So multiplying by 1/3 is the same as dividing by 3. So a lot of the times if they want you to divide by 3, they'll just tell you that R is 1/3, and then this is what you would multiply by. So 6 times 1/3, or 6 divided by 3, would be 2. And then 2 divided by 3, or 2 times 1/3, would be 2/3. And then if I multiply that by 1/3, so 2/3 times 1/3, I'm just going to multiply my fractions straight across. That'd be 2 over 9. And then 2 over 9 times 1/3 would be 2 over 27. So these would be my first 5 terms of this sequence. Alright, we want to write the first 5 terms again. A1, A2, A3, A4, A5. So A1 is 10. A2 I'm going to get by, if I look at my recursive formula here, this is telling me that in order to get, like let's say we're looking for A2, then I would need to take A1 and multiply it by negative 4. So this is really just telling me what I need to multiply by, and that's negative 4. So this would be negative 40, this would be positive 160, this would be negative 640, and then this would be positive 2,560 if you just keep multiplying that by negative 4. And look, the signs are alternating. Alright, now, just like with an arithmetic sequence, when we wanted to find a specific term in a sequence, we have that same type of formula for geometric. The formula is just different. So AN is whatever term you're trying to find. A1 is still the first term. R is just what you're multiplying by between your terms, and then N is the number of the terms. So if I'm looking for A50, I would plug 50 in right here for N. Alright, so let's look at a few of these types of problems. So if I'm trying to find A8, if A1 is -4 and R is -2, I'm going to write this formula up here. AN equals A1 R to the N minus 1. So I'm looking for A8. A1 is -4. R is -2. And you need to make sure that if you have a negative R value, you put that in parentheses when you plug it into the calculator. And so then N minus 1 would be 8 minus 1. And so I'm going to plug this in. So -4 times a -2, and then I'm going to go ahead and say that 8 minus 1 is 7, so raised to the 7th power, and so then that should give me for the 8th term 512. Alright, let's find A4. So pause the video and try this one and then come back and watch it and make sure you got it right. So A4 is going to equal A1, which is 1/2, R is 10, and then I would do 4 minus 1, which is 3. And so then if we plug that in, I'm going to do 1/2 times 10 raised to the 4 minus 1 was 3. So raised to the 3rd power gives me 500. And so my 4th term here should be 500. Alright, now we want to write a formula for the general term of each of these geometric sequences and then find A7. So this is basically asking us to find an explicit formula. And the easiest way to do this is to go back and use this. So AN equals A1 R to the N minus 1. And so then I'm going to use this to write a formula. So I'm not going to plug anything in for N at first, but I can find A1 and R by just looking at my sequence. I know A1 is 3. R is going to be, I'm multiplying each of those terms by 4, and so then the N minus 1 is going to be my exponent, and then that's my formula. And if I wanted to find A7, I would say 3 times 4 to the 7 minus 1, which is 6, and when I plug that in, 3 times 4 raised to the 6th is going to be 12,288. So my 7th term should be 12,288. Alright, same thing for this one. And then I want to talk to you about this sequence in particular, because sometimes it's hard to look at a sequence and just know what the R value is. And so let's look at an easy example. I can look at 3 and tell that I multiplied by 4 to get 12. If I could not do that, like let's say I'm stupid and I don't know multiplication at all, and I don't know 3 times 4 is 12. And so to find that, one thing that I could do is say 12 divided by 3. And 12 divided by 3 would give me that R value of 4. And so this one is kind of hard for me to look at and tell what the R value is going to be. Okay, it may be hard for you. It'll definitely be harder when you get to fractions sometimes to tell what you're multiplying by. But this, what I would do the same thing, -0.004, take the 2nd term and divide it by the 1st, and when you do that, it'll give you R. So -0.004 divided by 0.0004, that should give me -10. So -10 is R. And so when I write my formula, AN is going to be 0.0004 times -10 to the N minus 1, and I'm trying to find A7. So A7 is just going to be 0.0004 times -10 to the 7 minus 1, which is 6, and when I plug this in, 0.0004 times -10 raised to the 6th, that's just going to give me 400 for my 7th term. Alright. So let's look at these terms. It's wanting us to find the 10th term of each sequence. And so it gives me A11 and what R is. And so A11 is 8. I'm looking for the term before. Sometimes it helps me to find the next term just to see what I need to do. R is 1/2, so that would mean in order to get to this next term, I would multiply by 1/2, 8 by 1/2. And 8 times 1/2 would just give me 4. And so what I did to get from this one to a next term was cut it in half. So what I need to do to get from 8 to the term before it is the opposite and multiply it by 2. So that should be 16. So A10 should be 16 there. I'm going to do the same thing for this one. A11 is negative 1/3. And I'm going to come over here and do scratch work. And when I multiply negative 1/3 by 1/2, that's going to give me a negative 1/6. And so right here I multiplied by 1/2, or divided by 2. I can look at multiplying by 1/2 as dividing by 2. And so if I divided by 2 to get from here to there, I need to multiply by 2 to get from here to there. And so if I multiply this by 2, negative 1/3 times 2, be like 2 over 1, I would have negative 2 over 3. And you could check this to make sure that it's correct. If I took negative 2/3, ooh, that's ugly. If I took negative 2/3 and times that by 1/2, I would get negative 2 over 3 times 2 is 6, and that would reduce to 1/3, which is what I have here. So my 10th term would be negative 2/3. Now let's look at some word problems. I'm going to look at 2 with you. All right, so it says, suppose you have $1 the first day of the month, 2 the second, 4 the third, and so on. That is, each day you save twice as much as you did the day before. What will you put aside for savings on the 15th day? So this is asking specifically for a 15. So I'm going to use my formula. A15 is going to equal A1. N is going to be 15 minus 1. And so then I'm just going to plug in what I know. So A15 is going to equal, A1 is going to be 1. R is going to be 2 because 1 times 2 is 2. 2 times 2 is 4, and it tells me that I'm saving twice as much. So 2 would go here, and then this would be 14. And if you type this in and find what that is, that's going to end up giving you would be saving $16,384 on that 15th day of the month. So that's a lot of money. I would love to be able to do that. Oh well. Last problem, 8. And so you really want to pay attention to this one because a lot of people will miss this one. And a lot of times this sentence will not be in there. And so I'm going to mark it out, and hopefully that'll help you realize what you need to do when that sentence is not in there. So it says, a professional baseball player signs a contract with a beginning salary of $3 million for the first year. So I'm going to go ahead and write that one down. A1 equals $3 million for the first year, and it has an annual increase of 4% per year beginning in the second year. What's the athlete's salary for year 7 of the contract? So I've got this formula. I'm trying to find A7. A1 is 3 million. R is what I need to find. And then N is going to be 7 minus 1, which is 6. Now, R. I know this, first of all, is geometric because in order to take 4% of 3 million, I'd have to multiply by 0.04. Let's look at that. If I take $3 million and multiply, or take 4% of that, then that would give me only $120,000. And so if you use R as just 0.04, so if I were to put 0.04 right here as what I'm multiplying by, that would not be correct, because think about it. If you're making $3 million the first year, the second year, would you want to be making $120,000? Heck no, that's a big fat pay decrease. So what you want to do, instead of multiplying by 0.04 on one like this, you want to take your $3 million and you want 100% of what you make that first year plus an additional 4% raise. And so then that would give me my $3 million plus the 120 extra thousand that I should be making. And so my R value should be 1.04 on this one, and then you can just type that in to find out how much that'll be. So 3 million times 1.04, and I'm going to raise that to the 7 minus 1, which is 6, raised to the 6. And so in my 7th year there, I should be making $3,795,957, and I'm going to round that to the nearest cent, which would be 0.06.